Alright, I hope you guys are all having a bright sunny day today and your tulips are growing and all of those things. And if it's not quite the springtime where we're at right now, well then I hope you're having a good day anyways. Today what we're looking for is multiplying and dividing rational expressions. And then what that will lead to next is adding and subtracting, which when we talk about rational expressions, remember what we're talking about is fractions. Multiplying and dividing fractions, just a quick review. If I were to say a half times a half, we would all say top times top is 1, bottom times bottom is 4, 1/4. If I were to divide fractions, if I were to say something like 2/3 divided by 4/5, remember back to 5th, 6th grade, they'd say take your 2/3 and multiply it by the reciprocal of 4/5, which is 5/4. Top times top is 10, bottom times bottom is 12. Just a little refresher for you guys in those fractions and the multiplying and dividing. When we're simplifying rational expressions, let A, B, and C be non-zero real numbers or variable expressions. Then the following properties work. Well, if I have A times C on the top and B times C on the bottom, the C's go away and I end up with A over B. Just like if that was an X or if it was any other such thing. So let's take a look at example 1. Now example 1 is going to require us to harken back to the days of factoring. So I hope you have your thinking caps on and you're thinking about the snip method or you're thinking about some other method that you use to factor. I hope you remember that there's an X and an X in the beginning. I'm looking for numbers that when I multiply them I get 10, like 1 and 10 or 2 and 5. And when I combine them, when I add them, I get 7. So obviously 1 and 10 is not going to work. 2 and 5 works. When I multiply 2 and 5 together, I got a positive 10. When I added 2 and 5, I got a positive 7. Then they must both be plus plus. So I have x plus 2 over x plus 5. X squared minus 4, I hope you see that that is x squared minus 2 squared, or a difference of squares. So that's x plus 2 and x minus 2. And do we see anything the same on the top and the bottom? And I see an x plus 2 and an x plus 2. They eliminate each other, and I end up with x plus 5 over x minus 2. And that's the answer. So and a lot of this will work the same way. It's just more so about remembering how to factor. Multiply rational expressions. If I multiply, remember it's top times top and bottom times bottom. We're going to multiply top, or fancy people call that the numerator. And we're going to multiply the bottom, or the denominator. Okay? So if I have A over B times C over D, I get A, C over B, D. Makes sense. When we take a look at our next page here, example 2, if I look at that right away, and I have to multiply these things, I'll make example 2 just a little bit larger so we can focus in on it. We've got a checkpoint coming up, so we better know how to do this stuff. When I'm multiplying this, boy, it's a big mess. So the first step I'm going to take always is to factor anything that I can factor. Factor the numerator, factor the denominator. So when I look at this first numerator here, is there anything that goes into both of those? I think I heard somebody say 2x. And so I have 2x and x plus 2. Now, once I see that x plus 2, I start to think, okay, there's probably going to be an x plus 2 somewhere, or there might be. So if I need some hints on how to factor, you know, I already have a 2x down here, so I know those are going to start crossing each other out here in a minute. And so I'm going to look for that x plus 2 somewhere. Let's look down here. Okay, we're going to start with an x and an x. And numbers that multiply to be 12. Well, 1 and 12 and 2 and 6 and 3 and 4. And when I add them up, I get 4, or they're 4 away from each other. 2 and 6. All right? I'm going to put my 2 here and my 6 here. Now remember what we were saying. You got that x plus 2 there. Now when I multiplied the 6 and the 2 together, I got a negative 12. And when I added them, I got a negative 4. Well, that leads me to believe I got a negative 6 and a positive 2, which makes sense because something's going to cross cross out there in a moment. Now let's take a look at this one here. Now this one, we're going to try to factor it. Now they won't all factor, but in this section they do. But you know, not everything's factorable, just they're making some special cases for us here. So we have an x in the beginning there. Numbers that multiply to be 18, 1 and 18, 2 and 9, 3 and 6, and they combine to be 9. They add or subtract to be 9. Well, that looks like 3 and 6. And look here, I got an x minus 6 over here, so that might lead me to believe that there's a 6 involved in this too. So I'm going to put a 3, and I'm going to put a 6. When I multiply them together, I get a positive 18, but when I added them together, I got a negative 9, so they're both going to be negative. All right, let's do a little color change here. Now, let's take a look. What's the same on top as on bottom? Now, they say on the next step to multiply. Well, when you're multiplying, all you're doing is, if there's no adding and subtracting, if it's just all multiplying stuff, you're just putting a line through there. Anything same top and bottom. 2x, 2x. X plus 2, x plus 2. X minus 6, x minus 6. What am I left with? X minus 3. And that's my answer. All right, you guys go ahead and take a look at the next couple of checkpoints. Pause it, give yourself a minute or two, and see if you can figure it out without my help. All right, welcome back. Let's see what we have. I'm going to change my color back to something a little nicer. Hopefully, when you factored this one, you ended up with x minus 5 and x plus 3. And on the bottom, x plus 1 and x plus 3. All right. Now, you might need some practice doing those. There's a lot of different ways to factor. There's tons of them. The SNP method is certainly out there, and it's on my website. I think it's in Chapter 4 somewhere. It might help you to go back and refresh. Maybe I'll relink that to this page as well. If I take out the x plus 3's, I end up with my answer, x minus 5 over x plus 1. On the next one, kind of tricky, but when you look at stuff like this, right away, I hope you say, okay, they both have a 6, they both have an x. I can take a 6x out of them, and I have an x plus 3. All right? And then on the bottom, I have x minus 2 and x plus 3. And so those things are going to eliminate each other right away, those x plus 3's. The one on the right here, I have an x minus 2 and an x plus 1. Again, takes some practice for sure. And then on the bottom, x minus 8 and x plus 1. So if I start looking at things that are the same top and bottom, I get rid of the x plus 3's, I get rid of the x minus 2's, I get rid of the x plus 1's, and I end up with 6x divided by x minus 8 as an answer. Okay, hopefully you guys ended up with those as well. Let's take a look at example 3. In example 3 here, when I'm working on this, you see they have this x squared minus x plus 1. That kind of looks funky a little bit, but I'm gonna make it a fraction. So right away I'm gonna make it x squared minus x plus 1 over 1. Remember, all numbers are fractions. You just put them over 1. That means that I have the top x minus 4 times x squared minus x plus 1. And I'm sure some of you already thought, wait, aren't we supposed to factor that, Mr. Emeott? Yeah, you are, but the top does not factor that x squared. There's no numbers that multiply to be 1 that add to be negative 1. So it's not factorable, this piece right here. Not factorable. And that's okay, because if you notice on the bottom, something from way back, the Wayback Machine, we have what's called a sum of cubes. And the sum of cubes formula, you can look that up in your book. In the back of the book, it'll tell you what page it's on. But essentially it says if I have x cubed plus 1 cubed, because that's 1 cubed, it's going to look like x plus 1, and then I take that first number and I square it. I multiply them together and I subtract it, and then I take the last number and I square it. Now that looks a little familiar, doesn't it? They made this kind of nice for us that they put this here. This and this eliminate each other, and I get x minus 4 over x plus 1. Does that make sense? I hope that difference of cubes is the tricky, or the sum of cubes. We're going to do a difference of cubes in just a minute, and that's going to show up on the test and the quizzes, and so you got to be ready for that. Questions. Now, Mr. Emeott in his younger days would do stupid stuff, like he would stand in front of the room and he would talk about dividing fractions, and he would have a fraction on his body like a moron. And so maybe he would be wearing a piece of paper and it would say 3/4 like that, and he would say, well, I'm all proper and I'm ready for the dance and I'm happy, but when I divide fractions I have to do something a little different. I have to take that the second fraction and I have to turn it upside down. And then at this point Mr. Emeott would walk around the room on his hands, if you can imagine. About 20 pounds ago he would do that. So when we talk about dividing fractions, what I want you to think about is Mr. Emmeott's stupid self flipping over and multiplying fractions. And when he flipped over and multiplied fractions, the last time he did was about 10 years ago, and he fell on some unsuspecting little girl. And so he doesn't do that anymore. So what we have is AD over BC. Don't forget to flip that fraction right away. That's the first thing you have to do, is flip that fraction over, like Mr. Emeott flipping over. So what we have is, first thing, we're going to flip x squared plus 6x minus 7. We just took that, put it on the top, took the top, put it on the bottom. 8x squared minus 8x. Then factor. Then it's just dividing is exactly like multiplying. It's the same thing, you just got to flip first. And so what do we got here? I see that x plus 7 down here, and that's kind of giving me a hint that the numbers I got here are probably x plus 7 and x minus 1. And on the bottom, 8x goes into both of those things. And so I take an 8x out, and wouldn't you know it, it goes into there x minus 1 times. And so when I'm looking at what am I going to do here, it looks like x minus 1 and x minus 1 cancel out, and it leaves me with my answer, which is x plus 7 over 8x. All right, so flipping upside down when you're dealing with those things. You guys go ahead and do checkpoint 3 and 4. Take it, pause it, and then we'll go over it real quick. All right, welcome back. Thank you to those of you who are actually pausing the video and trying and doing your best. To those of you who just keep playing through, it's not the end of the world, but the problem is when it comes time for a test, you're not going to have all the practice that you need to be successful on the test. So please do as I ask. I'm not there in your room watching you watch this video, but if you do what I ask you to do, things are going to work out better for you in the end. Trust me. Okay, look what we have. X cubed minus 3 cubed. We have a difference of cubes. And we look up that difference of cubes formula. It's very similar to that sum of cubes formula. The only difference is it says x minus 3 in the beginning, and then it's a minus plus plus. That's how I remember it. X squared plus, multiply the two things together, 3x plus 9. And wouldn't you know it? It looks a little familiar, doesn't it? So if I take this thing and I eliminate them, I get negative 2x squared over x minus 3. And there's my answer. And take a look at number 4 here. On number 4, I have x minus 5, or I have a division. So the first thing I have to do is do x minus 5. And then if I factor this bottom while I'm doing it, I'm just going to pull out a 9x, call it x minus 2, times, and then I have to flip these things. And I can factor them, then flip them, or flip them, then factor them, but eventually I do have to flip them. The bottom one is 2x minus 1 and x minus 2. I hope you see that. And the top one is 2x minus 1 and x minus 5. So when I flip those things, I get the 2x minus 1 and x minus 2 up here. And on the bottom, I get 2x minus 1 and x minus 5. You see the one that ends in 5 ended up on the bottom. So x minus 5's went away, 2x minus 1's went away, x minus 2's went away, and I ended up with a 9x. Now, one of the biggest mistakes I see people do is they write 9x. Well, 9x is not on the top. 9x is on the bottom. So we have to make sure that we still leave that 1. See, there's always a 1 present on the top. So 1 over 9x. Just like there's a 1 on the bottom, but we generally don't write it. All right. Well, I hope you guys did a good job here. I hope you remembered what to do with fractions when Mr. Emeott is flipping upside down and he's falling on some poor suspecting girl who's sitting in her desk right here doing everything she's supposed to be doing, and Mr. Emmeott's goofing off. Instead of probably being an excellent teacher, he's probably being a crappy teacher. And here she's writing, and then here comes Mr. Emeott flipping upside down. Oh no! Oh no. And crash all over the place, and so that crash kind of looked like just like that. All right, you guys have a good day.